Hi, thanks for watching. It's Arthur from Cinema, and I will be demonstrating the first prototype of my synthesizer, named the µ-modular for now. Name might change, but I would like to take you along with an overview of the possibilities of the synth and the lessons learned, most importantly, and of course a few sounds. Let's get on to it. First, some close details of the synthesizer itself. I will be using my small camera for that, so you can have a closer look also on YouTube. The first part is the power. It runs on plus or minus 9 volts, and it is using a AC adapter, and this part transforms it into a stable plus 9 volts. These are two voltage controlled oscillators, my own design. One of the things missing on the PCB are the designators. I did not export the layer containing the designators incorrectly, so all pins are missing their functions. Not very handy, I know by heart, but it's very difficult. These three are 1 volt per octave. These two are tuning inputs. This is square out, and this is pulse out, and this is sawtooth out. This is pulse width. This is hard sync, and this is linear sync, I think. So you see, without designating, it's very hard to remember and understand the correct pins, but it doesn't matter that much. It is linear detune, by the way. This one, so this one should be hard sync. Find out in a moment. This is the voltage controlled filter. It uses a design made by Ray Wilson. It's an LM13700 integrated circuit over here. Resonance and a cutoff control. The cutoff was also voltage controlled by those two pins. This is the voltage controlled amplifier, own design based on the datasheet from the Z2180 voltage controlled integrated circuit. It is voltage controlled over here. There's two inputs. This is the audio in, that's the audio out. It's a little bit of a mess because I was very much prototyping this part, made some mistakes. Dual ADSR, designed by René Smits, used with permission. Full attack, decay, release and sustain possibilities. It has one trigger in, it has one trigger button, it has 3 voltage outputs varying between 0 and somewhat between 7.5 plus 7.5 volts. Second, ADSR. Both ADSR have a adjustable output, by the way. And this is my handy multifunctional part of the design. This is a 4 voltage controlled pots. These output a voltage on those two pins for the first potentiometer, those two for the second, and so on. All the way left is plus 5 volts, all the way right is minus 5 volts. A second design error, all the potentiometers are functioning the wrong way around. So clockwise is counterclockwise and counterclockwise is clockwise. Some footprint error by me. A audio mixer, 4 inputs and 1 controlled output, also a small, if you can see it over here, a small pin which also carries the output of the audio. Well, very short, that's the prototype of my first µ-modular synthesizer. Okay, let's explore the sonic possibilities of this prototype. Just fix my computer. Okay. Here it goes. The first example is the saw wave out of the first oscillator. Not adjustable. To have it adjustable in frequency, I can use the voltage out of one of these potentiometers. Each potentiometer offers a voltage in between plus 5 volts and minus 5 volts. So it has two outputs on this header. So just take one, use the 1 volt per octave in of the first 3 volts controlled oscillator. And if I just turn it down to nicely audible frequencies, it goes very low. And even if I use a second potentiometer with a second voltage and a second 1 volt per octave input for this oscillator and turn it all the way down, it goes way out of hearing range. Or way up, but you just have to believe me on that one. Okay. Let's reuse this second voltage potentiometer to have a listen to the pulse output. Pulse output is adjustable. As you can hear. Nice, sounds great. That's it for pulse. If I would like to use the arterial beat step, I can use the control voltage output of the beat step to adjust the frequency of the oscillator. As you can hear, just a little bit lower. Although that sounds great, I like to use the gate functionality also. Gate functionality comes through this jack, and gate functionality is usable by the voltage control amplifier. Just plug in the gate, plug in the audio in, and plug in the audio output. So voltage control amplifier is controlling the input and the output. And the gate of the arterial beat step is understood by the prototype. If I start the sequence, you can hear the gate functionality working properly on the prototype. Just check the time on camera. Just a minute or so left. If I'd like to use a more sophisticated gate, I can deploy the attack, decay, sustain, release ADSR generator on the prototype. So I just detach the gate output from into the voltage controlled amplifier, put the gate to the attack, decay, sustain. But first I can just test it by connecting the wire and pressing the button. You can hear the attack and the release working very nicely. So if I just attach the gate from the beat step, I suddenly have a lot more possibilities to shape the sound to my need, like a shorter release, a longer attack sound like this, should probably be logarithmic. This is the decay and the sustain. Sustain, short, decay, both very short. Takes away sound. Raindrops. These are all the possibilities of an ADSR component.